Good day. Today we shall be looking at a subtopic on limit of functions. So before we go, we would like to define what limit of function is. A function f of x is said to have a limit L, where L is a real number about the point x tends to a. If L is equal to the lim of f of x as x tends to a. What do we mean by this? We mean if this L here is a defined term, okay? After operating on this function, this lim means an operator, okay? From the word lim. Anytime you see this operator, it means you have to find the limit of this function when s tends to a, okay? What it means is that whenever we see s in an expression of f of x, okay, we put a, okay? So when we put a, after computing, the result is L, and L is a real number. We say that such a function, the limit of such a function exists. Now, there are cases where this L will not be a real number. Let's say, for example, in a given number line, R, this number L is in between the range of negative infinity and infinity. So what we are saying here is that this number L is in between negative infinity and positive infinity, where both negative infinity and positive infinity are not part of the set of numbers here. Okay, so in a case where this L becomes this or this, then we will say that the limit of this function does not exist. So let me come again. What we are saying here is that if the number L is equal to positive or negative infinity, then we'll say the limit of this function does not exist. Okay? So this number, negative infinity, including all the number in between the range here and infinity, are the number on the number lines. Just that these two numbers are unknown. So they are the two extremes number which are unknown. Okay, and anytime our result give such, we'll say the limit of such function does not exist. Again, there are some terms which look like numbers, but they are not. It is possible that when we compute this, we get such result. One of such form is that in the case where L is given by this term, okay, we'll call it a term because this term is not a number, though this is 0 over 0. 0 is a number, and what is that denominator is also a number. But that does not mean this is a number. Okay? Because this result is inconclusive. And what it means is that if you have to compute this term is indeterminate. Okay, so if the solution of this limit gives us 0 over 0, then we conclude that the limit of such function is indeterminate. However, such form can be rectified. Okay, so we also have some forms which are indeterminate. These are a case where 0 is to the power of 0 is also indeterminate. We can also have a case where infinity is raised to the power of 0. This is also indeterminate. We also have We also have a case where L could be infinity over infinity, infinity minus infinity, infinity multiplied by 0. All these terms starting from 0 over 0, 0 is power 0, infinity is power 0, infinity over infinity, infinity minus infinity, or 0 multiplied by infinity. These are terms of indeterminate. However, all these terms can be rectified. Okay, so we shall be giving one example at a time on each of the three things we have just discussed. The three things we have just discussed is that so we have discussed three things. So first is that if you have a solution which lies between negative infinity and infinity, we'll say such solution exists. In a case where we have either negative infinity or positive infinity, we'll say the limit of such function does not exist. The third case is a case where L give us any of the indeterminacy form, such as 0 over 0, 0 multiplied by 0, and what have you. Then in this case, we say such limit is indeterminate. So what we want to do now is to give example of a function which has a limit L, where L is a real number. Example of a function which either give or gives negative infinity or positive infinity. And we'll look at the example of a function which give us any of this structure. Okay, and then how do we rectify? We shall be looking at these three examples. The first one says we should evaluate the limit of 2x squared plus 3x minus 4 when x tends to 2. Okay, as we said earlier, when we are given something like this, what we do is wherever we see x in this expression, we substitute 2. So to do that, this will be, let's see, this is 2 square into 2 square, 2 into 2 square plus 3x so this will be equal to 2 multiplied by 4 plus 6 minus 4, and this will be equal to 8 plus 6 minus 4, and this is equal to 10. So the limit of this function when x tends to 2 is 10. Okay, we see that this 10 is defined and it can be seen on the real number line. So the limit of this function exists. For the second example again, when we substitute for x, we have 5 over negative 1 plus 1, and this will be equal to 5 upon 0. And this case is a case where the limit is undefined. And here we will write infinity to mean an undefined time. So here the limit of this does not exist. And this is not rectifiable. The limit does not exist at s tends to -1. Okay. So the third example, again, when we substitute for 2, what we have is 2 squared minus 5 into 2 plus 6 over 2 minus 2. Here, this gives 0 over 0, which is indeterminate. However, this is rectifiable, and it will be discussed in our next class.